Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire syllabus of IGCSE Cambridge Chemistry. The course code is 0620. I have covered all the exam boards of UK along with the international courses like EdXL, IGCSE, AQA, OCR, all of them. So if you belong to a different exam board, you can find your relevant playlist from the search menu on this channel. You can also follow me or join my community on school.com with the name of High School Chemistry. The link is given in the description. It's you can join it for free. You can participate in discussion forums. You can ask questions. You can attend a free lesson, one free lesson per month. And if you want more, there's a premium package available where you can attend 4 lessons per month for like per one lesson per week, where we cover the entire syllabus in around 40 days or in 40 lessons. So yeah, and if you also need one-on-one tutoring lessons, so you can there's a package for you. You can contact me on that community, and there's also a link of a Google form given in the description, so you can contact me by filling that Google form if you need one-on-one lessons. So state okay, so in this one, this is 6.3 reversible reactions and equilibrium, and it says that state that some chemical reactions are reversible as shown by the symbol. This is the symbol, right? Yeah. So now, what is a reversible reaction? So there are some reactions when where reactants, when they change into products, so the products, they can react back, they can react with each other, and they can convert back into reactants, right? So A plus B, these are the reactants, they are producing C plus D. So C and D, then they will react and they will produce A and B, right? So you can see that these two equations are the exact opposite of each other, right? So this is a reversible reaction. So now we write these, we merge these two, and A plus B, and then we use the symbol, right? And C and D. It means that this reaction can occur both ways, from left to right and right to left. So these are called reversible reactions. So one of the examples is N2, nitrogen. When it reacts with hydrogen gas, it produces ammonia. And when ammonia is produced, it decomposes, and it can change back into these reactants. So this is an example of a reversible reaction. All right, so I hope this is clear. Now we move on to the second topic, which is describe how changing the conditions can change the direction of a reversible reaction. A, the effect of heat on hydrated compounds. Okay, so we will talk about this first, effect of heat on hydrated compounds. So what are hydrated compounds? Hydrated, as when we say that stay hydrated, right, in summer. So what does it mean? It means that drink water, right? So those compounds that contain moisture or like contain water, water is trapped in the lattice of some salts. So these are called hydrated compounds, right? So uh, so yeah, hydrated salts or compounds contain water molecules in their structure, and the opposite of it is anhydrous. So hydrated compounds, salts containing water, salts, and or compounds containing water, and the opposite will be anhydrous, anhydrous. Anhydrous means without water. So salts or compounds without water, right? Okay, so these are the two terms that you need to differentiate, and you need to know that what is the difference between the term hydrated and anhydrous. Okay, now the effect of heat on hydrated compounds, like it is obvious, right? I mean, if we have a salt, that has like water molecules are trapped in the crystal system, for example. So when you heat it, what will happen? This water molecules, water will escape out of it, right? And its mass will reduce, right? So the dots, these the dots are representing water molecules, and now you can see that the water has been evaporated, and now the salt is without water, right? So by heating a hydrated compound, the water is evaporated, leaving, now this is called anhydrous compound. That is anhydrous, and this was hydrated, right? So I hope this is clear. And when water leaves a molecule or like salt, the mass, it decreases. Remember that. And by calculating the difference in mass, you can actually calculate that how much water was trapped, right? And all right, so now the next part B, the addition of water to anhydrous compounds. Okay, so now let's say this is an anhydrous compound. Now we need to add water, right? And limit it to copper to sulfate and cobalt to chloride. Okay, so we will take a look at these one by one. So the first one is copper to nitrate, copper to sulfate, sorry. Okay, so what happens to copper to sulfates? Remember that the hydrated form, when this salt contains water, the color is blue, right? And the anhydrous form, anhydrous copper sulfate, the one that is without water, that is white, right? Okay. So now you can see that now it is saying that the addition of water to anhydrous compound. So if it is anhydrous compound, so it will be a white crystalline solid, but when you add water into it, it will suddenly change its color to blue, right? And it will become hydrated. So, and the opposite can also occur if they give you a hydrated copper to sulfate and they ask you to heat it, so it's going to change color, right? So let me write it like this: copper to sulfate. So here, when we, this is yeah, so I'm gonna write hydrated, and like when we add water, right? So this is gonna change to blue, right? And yeah, this is when we heat it, so anhydrous, right? So heat, so it changes into white color. Yeah, so you need to remember it like this, right? And this is a memory-based question. You must memorize this. If you don't remember this, you will not be able to answer this question. And the next one is uh, cobalt 2 chloride. Okay, so the second one is cobalt 2 chloride. Yeah. So what happens to cobalt 2 chloride? Again, you have to remember. So hydrated, the crystals are pink. It will have a pink color. And anhydrous, it's a blue, right? This one is a bit tricky. It is not colorless, right? Both the forms are colored. So anhydrous without water is blue, and water, when water is added to cobalt 2 chloride, it turns pink. So remember this. This again, this is a memory-based question. So okay, let me write the equations for you guys as well. So for copper to sulfate, this is the equation. CuSO4 dot 5H2O. That is the formula for hydrated. You can see that 5 molecules of water are trapped in one molecule of H2SO4, right? CuSO4, copper sulfate, and it's a solid. And when it is heated, this is hydrated form. So when it is heated, and it will have a blue color, right? And when it is heated, it will be without water, because water evaporates and leaves only salt behind. And now this will have a white, this is the formula of anhydrous copper sulfate, which will have a white color, right? Okay, so I hope this is clear. Now we move on to, and you see the reversible reaction. So water leaving and water being added, right? So the forward reaction is when we are heating it, we are removing water, and the backward reaction is, the reverse reaction is when we are adding water. So we can write it water as separately like this, right? Now it is not a part of this anymore. That's why we have a plus sign here, and here you see this dot. It means that this water molecules, 5 water molecules, they are connected to this thing. Okay, I hope this is clear. Now for the equation for cobalt 2 chloride, it is CoCl2 plus dot, right? So dot 6H2O, and then reversible reaction CoCl2 plus 6H2O. Oh, I have to write 5H2O here. Yep. Okay, now the equation is balanced. Right, so this side, this is hydrated, and it will have a pink color. And now anhydrous, this side is anhydrous, and this side has a blue color. So the questions will ask that, what will happen that if we, heat a hydrated cobalt 2 chloride. So what will be the color change, this to this. So the question says that, they are heating cobalt 2 chloride. So if they're heating, so you start from, so they will say that you have hydrated, you have hydrated cobalt 2 chloride. So you will write pink to blue, right? And if the question says that we have anhydrous cobalt 2 chloride, and we are adding water, what will be the color change? So dash to dash. So this is going to be now blue to pink, right? So these are the type of questions that they ask related to this topic. So, and this will be all for the part 1 of reversible reactions and equilibrium. Now the rest of the topics, they are for extended, so those will be covered in the upcoming lesson, like part 2, right? So this will be all for today. I'll see you in the next one. Take care. Have a good day.